The arrival of Atlas astronomers believed they understood what to expect when 3I Atlas, the third confirmed interstellar visitor, slipped quietly into our solar system. They thought it would behave like countless comets before it, an icy traveler drifting silently past Mars, leaving behind a faint data trail before fading back into the endless dark. But almost immediately, those expectations shattered. Atlas refused to play by familiar rules. It didn't behave like a predictable comet, it performed like a cosmic drama unfolding in real time. At first, telescopes captured only a faint smudge of light, barely visible against the crowded backdrop of distant stars. Then, in less than 2 days, everything changed. The comet erupted in brilliance, its brightness increasing sixfold, a transformation so sudden that astronomers struggled to believe their own data. A vast emerald-green cloud of gas and dust bloomed around it, expanding into a glowing sphere nearly half the width of the Sun itself. This wasn't a gentle flicker. It was a full-scale awakening, a display of raw cosmic energy. All over the world, observatories turned their eyes toward it. What had once been a quiet object became a blazing beacon that dominated astronomical databases and headlines alike. Now, Atlas speeds toward Mars at nearly 70 kilometers per second, faster than any world that circles our Sun. At that pace, it could cross the distance from Earth to the Moon in just over an hour, a journey that once took Apollo astronauts 3 full days. By late October, when it nears the Sun, its speed will surge to nearly 68 kilometers per second, a pace rivaling humanity's fastest machine, NASA's Parker Solar Probe. But unlike the Parker probe, which needed years of gravity assists, Atlas gains this speed simply by falling, a natural descent powered by the Sun's irresistible pull. Its brightness too became a mystery of its own. During its outburst, it grew more than 40 times brighter than early measurements predicted. Yet even at that level, it remained invisible to human eyes, a hidden spectacle only telescopes could witness. Through those lenses, it appeared as a fragile, ghost-like blur of light, but what they saw stretched hundreds of thousands of kilometers wide, a shimmering cloud, as if a planet were dissolving into mist before their eyes. Its orbit revealed a deeper secret: Atlas would never return. Unlike comets locked in long, looping orbits around the Sun, this one followed a hyperbolic path, an open arc that guarantees its departure forever. Atlas is a true wanderer, a traveler from the cold void between the stars, carrying ancient chemistry forged in a distant system, perhaps millions, even billions of years ago. That fleeting presence makes every moment of observation precious. By October 21st, its angle from the Sun, what astronomers call solar elongation, will shrink below 30 degrees, and the comet will vanish into the Sun's glare, beyond the reach of human sight. Its most spectacular phase will unfold in complete secrecy. Imagine knowing that history is happening right now in the heavens, and not being able to see it. That's the frustration driving astronomers across the world into a race against time. Within hours of Atlas's first brightness spike, amateur observers began sounding alarms, databases lit up, and major observatories scrambled for viewing time. The Hubble Space Telescope scheduled emergency ultraviolet imaging. The James Webb Space Telescope, normally booked years ahead, made room for precious hours of infrared scans. Even NASA's SphereX mission shifted its timeline just to capture this the secrets of Atlas. The results of those observations shocked the scientific world. Webb's instruments detected something astonishing. Atlas had 8 times more carbon dioxide than water, a ratio no comet had ever displayed before. Most comets are powered by water ice, with carbon dioxide and monoxide as minor players. But Atlas is different. Its eruptions are driven by carbon dioxide, a chemical imbalance that challenges everything scientists thought they knew. What kind of alien environment could create such an unusual recipe, and preserve it for millions of years across interstellar space? Then, another surprise. Atlas's glow shifted dramatically. In September, it began radiating an eerie, electric green. Normally, that color comes from carbon molecules fluorescing under sunlight. But Atlas told a different story. Its glow came from oxygen atoms torn apart from carbon dioxide by the sun's radiation. It was a natural reaction, yes, but one that rewrote expectations of comet chemistry and behavior. And then came the strangest phenomenon of all, the anti-tail. Comet tails usually stream away from the sun, pushed outward by solar wind and radiation pressure. But Atlas developed a luminous spike that seemed to point toward the sun. At first, astronomers blamed perspective. Perhaps it was just the way Earth's orbit crossed the comet's path. But when multiple observatories confirmed the same feature, it became clear something unusual was happening. Some proposed uneven gas jets shooting dust sunward. Others modeled complex plasma interactions. And a few dared to ask, could it be something not entirely natural? Most scientists stayed cautious. Extraordinary claims demand extraordinary evidence. Yet one fact remained undeniable: Atlas was unlike anything seen before. As Earth loses sight of it, a new chapter begins around Mars. A fleet of spacecraft orbiting the red planet is preparing to observe it next. NASA's Mars Reconnaissance Orbiter may capture images of the comet's icy core. ESA's Mars Express will map the massive green coma in wide detail. The Trace Gas Orbiter can study its unusual chemistry. Even MAVEN, built to study Mars' atmosphere, will detect the ultraviolet glow of the comet's expanding cloud. Within weeks, these spacecraft were patched, reprogrammed, and repurposed, transformed into a coordinated deep space observatory chasing a visitor none of them were designed to study. What happens next remains uncertain. Some scientists predict Atlas will survive its pass around the Sun, gradually fading as it travels back into the darkness. Others suspect its icy heart will fracture, shattering into clouds of glowing debris. Another possibility looms larger still: total disintegration. A final, spectacular burst of light, followed by silence. Whatever its fate, Atlas will forever change how we view interstellar visitors. These objects are more than curiosities. They are time capsules, carrying chemistry from long-lost star systems. They may hold answers to how planets form, how organic molecules spread, and how the seeds of life travel across the galaxy. The green glow, the anti-tail, the violent outbursts, they are not random events. They are messages written in dust and light from a world we will never touch. For a brief moment, humanity has the privilege to listen. By November, Atlas will vanish again, slipping back into the Black Sea between stars, never to return. Whatever secrets it carries will remain out there, hidden forever in the dark. But its passing has already left a mark. A reminder that the universe is stranger, more dynamic, and more mysterious than we ever dared to imagine. And that's why this story matters. Because this isn't just about astronomy. It's about our place in a cosmos full of travelers, some silent, some spectacular, each one reminding us that even after centuries of watching the skies, we are still only at the beginning of understanding. So if this journey moved you, if the mysteries of the stars still call to you, stay with us. Because the sky is full of visitors, and every one of them has a story worth telling.